Welcome everyone. This is an overview session on Oracle Database Programming Interface for C, ODPI-C. I will throw over to Anthony Tuninger in a moment. My name is Christopher Jones. I also work in the Data Access Development Group in Oracle Database. ODPI-C is an easy API for C programmers and obviously C++ programmers. It simplifies development and is aimed mostly at people who are writing language drivers on top of the Oracle client libraries, want to connect to the Oracle database. OCI is widely used, fully featured, very flexible. ODPI-C is a little simpler, has a lot of extra functionality on top to make life easier for you. It exposes all of the database features that you want, but does things like resource management, wraps things like lobs, so it makes working with lobs easier, does a lot with connection management to make sure the connections are available when you want them to be. And key things here are that it can be built as a shared library, but generally we see it incorporated directly into a language driver, or you can use it into your own projects. Has no compile time dependencies. At runtime, it will use DLOpen that will open the Oracle client libraries. It will work with 11.2 or later. Runtime, it will check what functionality is available in those libraries and in the database that you're connected to, and will obviously give you the functionality you want or produce errors if you try and use something which is not available in the particular version you're connected to. Has a lot of features. I won't go through all of these. You can read about this online. One the key thing, of course, is that actually it sits on top of OCI, and therefore it has access to things which underlie OCI, such as the OracleNet features for encrypted network communication, high availability events, some high-level features which really make your applications stable and secure. This is a kind of rough overview. It's not particularly complete. We've got new languages coming along all the time. I know a driver for the NIM language sits on top of ODPI-C. You can see that we look after a number of drivers, the newer drivers that we look after, Python and Node, or Python's been refactored to work on top of ODPI-C, but as we work heavily on these, we refactor them to work on the ODPI-C layer. That talks down to the Oracle Call Interface layer, and a shout out to our third-party driver maintainers who do a lot of good work there, whether or not they're using ODPI-C or not. Under the covers, just using Python, CX Oracle, for example, users won't even know that they're using ODPI-C. As far as they're concerned, they just get the driver, CX Oracle. They install CX Oracle with their Python. Separately on their machine, they'll install the Oracle Call Interface libraries, typically from Instant Client, and everything works nicely. So that let me throw over to Anthony.
So as Chris mentioned, ODPI-C stands for Oracle Database Programming Interface for C, and it's intended as a light or tiny wrapper on top of the Oracle call interfaces to simplify connecting to the Oracle database and doing the features that you would normally do. It's primarily focused on drivers. That's where it's been used the most, but it is suitable for C-based applications as well. And we have seen some questions regarding that. It's about 3 years old now. And as mentioned, it's used by quite a few drivers already. We do testing on Linux, Windows, and Mac OS, although it has been used successfully on other platforms like Solaris and AIX. In any case, the code base is intended to be cross-platform and should, at least in theory, work on all the platforms that OCI itself supports. So one of the biggest advantages in my mind for using ODPI-C is the fact that it dynamically loads the Oracle call interface libraries. So what this allows ODPI-C to do is support versions from 11.2 through 19, and actually now 20, with a single binary build. And you can simply flip between different versions simply by changing LD library path, or on Linux and Friends, or path on Windows. And because of the fact that ODPI-C uses dynamic loading of the OCI shared library, it also does not use header files provided by OCI, so it can be built independently. ODPI-C uses its own definitions. So another advantage to using ODPI-C is the reduction in the number of lines of code needed to write drivers and applications. OCI's focus has been on creating a very generic interface, and it's also had a number of years of enhancements kind of accreted onto the side of it. So ODPI-C has taken the common ways of connecting to databases and executing statements and has simplified those interfaces considerably, as I think you'll see. And I think a last focus of ODPI-C has been to improve the safety of drivers and applications using it. So ODPI-C uses a reference counting mechanism to ensure that the lifetime of various structures is easily controlled and managed. It also checks parameters a lot more rigorously than OCI itself does, things like null pointer checks. It eliminates the need for typecasting, which is very common in OCI, and it can frequently be a source of problems in people's code. One other thing is ODPI-C also does have kind of built-in debugging. It's enabled by setting an environment variable, DPI debug level, and then it prints out lines to standard error with a thread number and a date and some information about what's going on. I can show you how that works as well. All right, so now I'll show you the, unless you have questions before I get into like actual code. I'm assuming no. All right, so this right here is,
sorry, Anthony.
yeah.
Anthony, so one quick question. So when we say people can use the ODPI layer, we recommend that they pick the latest copy, right? Because that will have the macros or definitions picking the latest Oracle client. Is that correct?
Yeah, that's
because
correct.
we are redefining all of them. Okay, okay. So
Yeah,
depending on runtime library, they will get the capabilities. But for, I mean, building or, I mean, whatever they plan to use for their products, we recommend always the latest. Is that correct? So that works with every Oracle client runtime.
Yes, yeah, the current version goes all the way from 11.2 to 20. We haven't actually dropped any version support yet. At some point, we'll probably drop version 11 support. And at that point, if you still needed that for some reason, then you would have to use an older version. But for now, everything is supported by the latest. Yeah.
A small nit, I guess you've got a tagged release, which only goes up to what, 19, but the master branch has got all your 20 changes. So it's public if people want to pick it up from master.
Yeah. Yeah.
Okay. Yeah.
All right. So here is the directory structure of a simple checked out version of the repository, which you can find on GitHub, or as it's on ALM as well internally. So there's a doc directory, and that doc contains restructured text files, and it also includes, if you build it, you'll see there's HTML here. There's an index.html, so you can build the documentation locally and look at it. That, of course, is also on GitHub in the HTML version.
So you just want to quickly show people how to build it?
Oh, sure. Make.
Simple.
And there you are. And that will rebuild the this build if necessary, right? If we go make clean and you look inside it, oops, there's no, the build directory is empty. Come on, I can't type. And then if you make it again, there they are. So the next directory here is this embed directory. This is just a simplification for drivers that want to embed the code directly into theirs. If you look at DPI.C, all this does is simply includes all the source files that are relevant. This is not actually done in either the Python or Node drivers. We actually include these files independently. But this is an option, and some drivers are using this. So it's convenience. There is only one include file, dpi.h. I'll show you that in a moment. Then we have samples. There's a bunch of samples here, which I'll show you also in a bit. Then we have the actual source code, which is right in the src directory. And then we have finally the test directory, and that contains the test suite that's been developed. I'll show you a little bit about that too as well. And you can see here there's a makefile, and that's for building on platforms other than Windows. And then you can see there's a makefile.win32, and that's specifically for Windows. And to make, it's simply make.
We should note that's really just a sample makefile. I mean, it does pretty much what everybody would need, but it's certainly something people might want to customize for their own applications, compilers, etc.
Well, this builds the shared library if you wish to use it that way, instead of embedding the code directly. And some have done it that way as well, mostly for applications, not drivers. Yeah. All right, so inside the include directory, there's the one file. And you'll note here, I've made sure that every symbol that's used in ODPI-C has the prefix DPI in front of it. You'll see that everywhere. You'll see here as well that I'm using the standard fixed width integer types, int8, int16, and 32_t, and so forth, not the OCI versions thereof, UB4 and UB8 and so forth. That's, you can see that, you know, standard int.h. This here defines the version number. So you can see the current, it's 340-dev. This is master. And this is just a nice little helper function here to create the default driver name, which is ODPI-C:. This, of course, is what will be seen in SQL in the database when you're connecting to the database, unless as a driver you override it. And of course that is done by Python and Node drivers, since we built them, but others may or may not have done so. I'll show you how that can be done as well. And as you can see here, the default fetch array size is 100. That's of course overridable. They also have a default ping interval of 60. That's for when you're getting connections from a session pool. By default, what will happen is after 60 seconds of inactivity on a particular session, it will force a full ping. That's changeable, of course. And the ping timeout is 5,000 or 5 seconds by default. These are just a bunch of constants. You'll see here DPI success and DPI failure. Those are used exclusively for all functions. They all return an integer, and they all return either a 0 or a -1. There are no exceptions. OCI does things a little differently. They return an error flag or an error code instead, or a partial error code. This only returns success and failure. These are the constants used for debugging. I can show you how that works after. And we have a whole...
Actually, they're really used for tracing rather than debugging, I guess. So they just print, you set the values and you get screen output.
Yeah,
to the level
they trace,
yep.
But I use them for debugging frequently.
Okay.
Yeah.
Actually, quick question. So success with info is not returned, right? Only success and failure.
Yes, all functions return either DPI success or DPI failure. Yep.
No success with info at this point of time.
No such what?
No success with info.
No, there is no such thing. Yeah. I do have added support in a sense for success with info or warnings, which I can show you afterward.
Okay.
Then we have enumeration. There's a whole pile of them. These are the connection or pool authorization modes. Then you've got connection close modes, pool creation modes, DQ modes, whole bunch of different types here. You can look at them all. They're all options that are public. You'll note they look similar to the OCI ones. So here are what I've called the native C types. These are the types that are returned. So OCI, of course, has its own special types: OCI date time, OCI lob locator, and so forth. And I have used these types here as the native types. So you have the basic ones, the two integers, float and double. You got bytes, that's used for both strings and raw. Then you've got timestamp, that's used for date and timestamp with time zone, and timestamp with local time zone. And then you've got the two interval types. Then you've got lobs, objects, statements or cursors, booleans, and row IDs. And so these all have representations in ODPI-C. And then here we've got a list of all the Oracle types that are supported by ODPI-C. And they should look very familiar to you. Bunch more enumerations, bunch of soda things. Here's all the statement types, subscriptions. And these are what I call handle types. So these are structures that are not exposed publicly. They use opaque handles. So that's what these are. So you got connections, pools, statements or cursors, variables, lobs, objects, object attributes, object types, row IDs, subscriptions, DQ options, NQ options, and message props. These last three are for AQ. And then here are they defined. So these are what I've called the complex native data types. So up above you had DPI native type bytes. So this is represented by this DPI bytes structure. So that has a pointer and a length and an encoding. So for raw, of course, encoding is null. But for strings, this encoding will be filled in with whatever encoding is relevant. This, of course, is known already by the connection, but it's stored here as a convenience for the user.
Question. Any reason you chose to not use OCI types directly and have these native types instead of OCI types?
Which OCI types are you thinking about?
UB4 and HANA text and all those, right?
Oh, yeah. Most people are going to be more familiar with the standard types like SP4. Nobody knows what that means unless you're an Oracle person. Whereas int32_t, they know what that means. So, and they're identical in terms of how they work. And aura text, of course, is again an Oracle specific thing. So the intent here is to make it as friendly as possible to non-Oracle people.
Mm-hmm. Okay.
Yeah.
Okay, thanks. Yeah.
You have three types, right? One is a native type, one is DB type, third is NJS type, right?
Well, this is ODPI-C only, so there's only two.
Two, okay.
In this case. Yeah, yeah. But yeah, at Node, there's a little bit of the Node driver has its own representation of types, of course. So this is the interval day second, when that's used, in the interval year month. And then we've got the timestamp.
Sorry,
Yep.
Anthony. For the byte stream, right? I mean, you have char star, I believe, right? Slightly if we go up. Should it be unsigned char there?
Well, technically, I suppose I could have done uint8_t or something to that effect, right, instead. It doesn't really matter, or for that matter, void. It's just a pointer in this case. And
bytes are fine. Yeah, char is fine. It's just should it be unsigned is what I mean. Later, if you're casting it, let's say somewhere when you're actually referring to the values? Would it cause any problem or no?
No, no, it doesn't. I'll show you how these actually get used, because there's a discriminated
Okay,
union
sure.
that follows. Yeah.
Sure, yeah.
So here you can see the timestamp. So it's got year, month, day, hour, minute, second, of course, in fractional second, and then the time zone offsets. So this covers, like I said, dates, and then all of the 3 Oracle timestamp types. These are just forward declarations of all the other types that are exposed, and you can see there's quite a few of them. So this is the union that is used for all the data that's exposed in variables. So you can see here we've got int for booleans, and then int64_t for int64, and so forth, right? These are all the different native types, as you noted above, right? The DPI native type, that's all of these.
How come you don't have the type, which type it is in the structure itself? The structure is basically unit of bullet data, right?
Yeah, you have to know. So in this case, because a variable, it has the type there, the object attributes have the type there. So it's not available in the buffer for objects. So rather than creating an entirely separate structure, I just use one structure. So yes, you have to know what type it is, because otherwise, of course, you're going to get garbage.
Hopefully you'll explain more what a variable is.
Oh yeah. Yes, I will explain what a variable is. So here's the context. That's not as commonly used.
Anthony, okay, Anthony, here you have actually timestamp and intervals as not as pointers, but you have lob as pointer, right? And statement.
Yes,
so, I mean, are you not using the OCI descriptors underneath the timestamp and interval DS? Or any reason for not choosing them as pointers? Because, I mean, normally we are used to looking at lob and timestamp and all of this in a similar way when it comes to descriptors. But here, yeah, you're using pointers for some and not for.
Well, yeah. These last 4 here are actually ODPI-C types. They have a handle, so to speak, so they're exposed publicly as they're objects in their own right, whereas these are not. So that's why these are all done directly inline, so there's no pointers, whereas these are. Hopefully, when I get a little bit further along, you'll be able to understand what that means. So app context, yeah, go ahead.
No, go ahead, Anthony, yeah.
Okay. Anyway, app context, this has got that whole namespace and name and value business. This is used for when you're logging in to the database and want to set a bunch of application context. It's not particularly commonly used, but it is supported here. This is the structure that's used for that. And then this structure here, DPI common create params, that's used for creating standalone connections and session pools. So these are the common parameters. So you can see here, there's this create mode that's equivalent to, like, you know, OCI, threaded, and all those sorts of modes. You've got the encoding and the national encoding, and you've got the addition and the driver name. See, in this, so this is where you can override the defaults. If this is not specified when you create the standalone connection or pool, then you'll get the default, which is the ODPI-C and the version number. And this is the structure used for creating connections. You can see there's lots of different options here. So OCI, of course, uses OCI adder set and the like. ODPI-C does not. So there is a convenience function for setting all of these parameters to default values. DPI context underscore init con create params, which I'll show you in a bit. But of course, you can also manipulate this yourself manually. So you can see the different things that are available. You got the different auth modes. That's for whether you want sysdba or sysauthor and the like. You got the connection class, purity. If you want to change the password on connect, you can set that here. You can have your app context if you want to do that. So this is an array of app contexts and the number of them.
Would you have multiple app context here?
Yes, you can have multiple. Yeah, this is an array of these, right? And this tells you how many there are.
But in practical, only one app context will be there, right?
Oh, no, you can have as many as you like.
Oh, okay.
Yeah. Yeah. This is a Boolean external auth, whether that's enabled or not. There's also this ability external handle. You can create an ODPI-C connection using an existing service context handle. That's what this is about. This pool is to indicate whether you're creating a connection from a pool, i.e. acquiring a connection from a pool. And then you got the tag and the match any tag. And then these are outs that are done after you acquire a connection from the pool. It gives you the tag that was actually retrieved. And then you got the sharding columns, and then you've got this other out new session that tells you whether a new session was created. This is only for pools as well. So here is the DPI data that's used for variables, which I'll show you in a bit as well. Is null is just a simple Boolean flag. OCI uses, I think, 0 and -1, and this uses a Boolean, so 0 and 1 instead. And then, of course, you've got a reference to this DPI data buffer. That's that discriminated union I showed you above. So this structure is used for providing metadata about data types. So this is used for variables. It's also used for object metadata. So the type of data that's found in an array or an attribute. So I've separated them all out. So you can see here, you've got the Oracle type number and the default native type number. I've got the OCI type code, which I use internally, but which is also available externally if you're interested. The DB size in bytes, the client size in bytes, because sometimes these are different depending on what you've got for your encodings. Your size in characters, precision scale, and your fractional seconds precision. And then, of course, an object type, if this isn't referring to an object type. So this comes back when you are looking at query metadata or object type metadata. And then I've got this structure for encoding info. This lets you know the maximum number of bytes per character for both the encoding and the national encoding. Then we've got error info. This is the way errors are retrieved from ODPI-C. So you don't call, yeah, go ahead.
Sorry, going back to the encoding, I assume that's the client side, DPI side, right? Max bytes rather than the database side.
Yeah.
Okay.
Yeah, this is the encoding as far as the client is concerned.
Mm-hmm.
Yeah. So this error info structure defines the various bits of information that will be retrieved when you call DPI context get error. So this code here is the Oracle code. And then we've got the old offset, which is only 16 bits. And we have a new offset, which is 32 bits. This one will get dropped at some point. Then we got the message.
While you're just at that point, do you want to talk a little bit about how you're handling those sort of upgrade issues from version to version of ODPI-C?
Yeah, so this version, this field right here was added. So of course, if you simply went ahead and used the version, the new version, you would get the wrong size of the structure. So what I have done is we've stated that ODPI-C, the version that you're actually using in your code that you compiled, and the version that you're actually using at runtime, the major versions have to match. And the minor versions have to be less than or equal to. And that's checked when you initialize the library. I can quickly show that, DPI context _ create. So here you pass in the major version and the minor version. And so what'll happen is I check to make sure that that's true. The major versions match and the minor version is less or equal to. And if that's the case, everything proceeds. And because you've passed this in, I know what the minor version is, and therefore I can adjust the structure sizes. I can show you some of that code after. So this encoding indicates here, so there's the message, and then this encoding indicates what encoding this message is in. Then you've got the function name and the action. These are internally passed along. So the user can know which ODPI-C function failed and what it was doing at that particular point. This SQL state is there as a convenience. This is recoverable is the new feature that's available in 12 that indicates whether the error is recoverable or not. If it's not an OCI error, then this will be false anyway. This one is new. This is warning. This is the one that indicates whether this error is actually a success with info error. Then we've got the object attribute information. This has just got its name and then the type information, which you saw earlier. On object type itself, you've got the schema, the name, whether it's a collection or not, and then the element type info. It's another type structure, if that's relevant, of course, and of course the number of attributes.
It might be worth pointing out this is the Oracle objects. Yeah, that's the
Yes.
database objects.
Yeah. And here are the pool creation parameters. So you've got min and max sessions and session increment. The ping interval, which I talked about earlier, and the ping timeout, and whether it's homogeneous, whether you're using external authentication. The get mode, that's the whether you're doing wait or timed wait or no wait. You got the pool name that comes out afterward, after you've successfully created the pool. You got your timeout, your wait timeout, and your max lifetime session, and then this new one for 12.2, which is this PL/SQL fix-up callback. And then the sharding thing, which is max number of sessions per shard. So some of these were added afterward. I'll show you again how that's dealt with. So here's the query information. This is for query metadata. You've got your name, and then you've got your type information, which I showed you above, and you've also got this flag, whether null is okay or not. Now that one is not, it could have potentially been put in here, but this is used for objects as well, which don't have this flag, so I left it out. Then you got the sharding key columns. Again, you've got your Oracle type and native type, and then your value, which is represented by this DPI data buffer. You've got the SOTA collection names. This is when you're getting collection names from the database. So you've got the number of names and you've got the actual names themselves as your array. This is returned from the function for getting those collection names. Then we've got a structure for SOTA operations. So these are the different options you can do, right? You've got the keys, which is an array. You've got just a single key. You got a version, you've got a filter, skip limit, and fetch array size. This last one is new for 20. And then here is statement information. So this indicates the statement type is the real thing, really. And then these are just convenience that just tell you whether the statement refers to a query or is PL SQL, DDL or DML. And there's also this flag, is it returning or not? So those ones are for convenience. This is the type for subscriptions. For the callback, they simply have a context, which is supplied by the application, and then, of course, the message. So for creating subscriptions, these are all the different parameters you can pass here as well. Subscription namespace, protocol, quality of service, what operations you're interested in, what port number, a timeout, the name, if you have one that's relevant, the callback context. If you're using multiple subscribers, then you can specify the recipient name and the IP address. This is for server-based server-based AQ. There's also client-based, which is new. Then you've got your grouping stuff, and then the out for the registration ID, and then of course a Boolean indicating whether you want client initiated or server initiated. This is the message that is sent when a subscription callback is invoked. So you get the event type, which is going to be one of those event type enumeration noted above. You got the database name it came from. You've got an array of tables, if that's relevant. You've got an array of queries, if that's relevant. You've got error information, if an error occurred while acquiring that message. You've got the transaction ID, whether it's...
So Anthony, does any of the ODPI user or drivers subscribe for event HA subscriptions also? Or
for which
basically
ones?
For do any of the ODPI users or the drivers which are using ODPI, do they subscribe for HA events also directly, or is this structure basically for AQ notifications?
It's intended for AQ. I did try one of the high availability ones, and it did work, but it's not really intended for that. It's intended for the AQ and CQN.
All right. Okay.
Yeah. So here you got your Q and your consumer, and this is for the AQ stuff. This is if you've got queries. This is going to tell you its ID, the query ID, the operation that took place, which is a set of ORed operations, and the number of tables, an array of tables. If you've indicated that you want rows, you're going to get the list of row IDs in here. I mean, it's not a list, it's just a row ID in this particular one. Because in a table, you specify what operation took place on that table, the name of the table, and if you asked for rows, you'll get an array of rows. So this version information here, this is for getting back client version information and server version information. This last one here is just a convenience. It's generated from all these bits and pieces. Okay, so DPI context. This structure is used at the very beginning of every program. So every ODPI-C program starts with a call to this method, DPI context _ create. And as I specified before, you specify the major version, minor version, and you get back error information. This is the only one that actually returns error information. All the rest, as you can see here, don't. You'll get back an DPI failure, and then you're supposed to call this method, DPI context get error. So errors themselves are stored in a thread safe manner. So each thread has its own error buffer. And so it's safe to call this after the function has been called, so long as you call it before you make invoke another ODPI-C function, because it gets cleared as soon as you do that.
Anthony, just jumping back to the major and minor versions, typically people would pass in the constants which are defined in the DPI.h file anyway.
Yes, well, they're supposed to.
Supposed to, yeah.
Yeah.
And therefore makes the tight coupling between that caller side and the application and the expected ODPI-C library in the back end.
Yep. And again, it's kind of a moot point if you're actually compiling all the source code into your driver anyway. The values will never change and they'll always work. So it's just when you have a standalone library like live ODPI-C.so, then it matters. So all these methods here are used for initializing the structures to default values. So those are convenience ones. Some of those have a large number of parameters, so setting them all is kind of potentially painful. So this allows you to default them nicely. So before I go there, I will show you, oops, over here. So for example here, this subscription creation params, this is the actual code for it. You'll see here it checks to see, hey, if the minor version is greater than 2, then we know that we're good. We can just call it with the value that was passed directly. But if it wasn't, if it's less than or equal to 2, then we use this local parameters, and instead we copy across just the size for version 3.2 or for the size for version 3.0. So that's how this is done.
While you're there, you may want to just point out your naming convention, whereas I see on about line 329 or something like that, you've got the double underscore.
Yep.
You've got camel case, single underscores, double underscores. What's that all about?
Yep. So all of the methods start with DPI and the name of the structure that they operate on. So in this case, DPI context. Then there's an underscore, and then there's a lowercase letter. And if there's more than one word, then it's using camel case. That's for a public function. If it's an internal function like this one, it's got 2 underscores in between the name, the prefix, and the name of the function. And yeah, go ahead.
It's just a little bit tricky because a bit further down you've got something which has got a double underscore with the same name as the one with the single underscore, so people just need to be a little careful when they're doing coding on that.
Yeah, I've done that in a number of cases. So this is the public one, so you see it's only got 1. And then you see this one, which has got 2. That's the private one. So you'll also note that every single one of these starts out with an error structure, DPI error. And then they call this DPI gen __ start public FN. So every single one of these starts this. You have to pass in your context, or rather you have to pass in a handle of some kind, and this tells you what kind of handle. This is the name of the function, so that goes into the FN name on errors. And this initializes this error. So the first time it starts up, it's going to go ahead and allocate for a particular thread an error buffer. And that's going to make sure this happens right here. If it fails, we call end public function, and we pass in that error. So you'll see that's going to happen down here. You get the success. So in all the public functions, they all have this going on. And this is a macro that simply checks to make sure that this value is not null. And if it is, it raises an error. Let me see if I've got any in here. Yeah.
So, this DPI context, what is the scope of that, and how do you expect the upper layer to use this? Is it like 1 per thread we need to create, or is it like 1 per connection or 1 per connection pool, right? So how are we supposed to have these DPI contexts? And there's an object, right? DPI context object.
It is.
Yeah,
And
so.
you only need one. Because, I mean, you can create more if you want, but there's no real advantage to doing so. Because nothing really hangs off the context itself.
Okay, so it's something like an ENV, process ENV?
Kind of like that, yeah. It's all it's meant to do is kind of initialize the library to begin with, and make sure that the major and minor versions match. And yeah, that's all. And it does the basic initialization that is required for the library to function.
Okay.
So you'll see here, there's DPI error underbar set. And here, this check context handle, that's the action that goes into the error information. And this is the error number right here. So, and the value that follows this is var args. So this is just information for that particular error. Go back in here. So DPI-Con is representing connections. There's a lot of different methods here. You'll note that all of these have an add ref. That's because I remember I talked about reference counting. So when you call DPI-Con underscore create, it returns to you a connection with a reference count of 1. If you need to use this in multiple locations independently, then you would call DPI-Con underscore add ref to add one reference count, 1 to the reference count. And then, of course, there is equivalent DPI-Con underscore release, which releases a reference to that connection. So you got to make sure you match those two. So all these are just the public functions that do all a bunch of different things here. I'm not gonna, you can look at those. So there's the release. There it is. So you'll see that in all of these. And you'll note that, see, for example, I created multiple methods for each attribute that's relevant. So there's set call timeout, set client identifier, set client info. OCI used the standard OCI adder set, and I did not do that in order to avoid casting. And it makes it easier to read as well when you're looking at actual code. So these methods here, these DPI data methods, these are all convenience methods. They are not necessary because, of course, you can access them, access the structures directly. But unions are not supported by, for example, Go. So these are needed by them. And sometimes they're just convenience. They're just one-liners that reference the structure or the union, sorry. So that's what all these are.
So Anthony, regarding the end-to-end tracing functions, you had some setting DB ops and setting client identifier. So does DPI set any of the values by default, or do the drivers do? I mean, if you know, like Node.js, Go, and all of this, Python, do they set some of these attributes by default?
No, they don't set them at all. Like the function name is an ODPI-C function name, and the action is the ODPI-C action. The drivers don't deal with that at all.
So they are exposed all the way for the application to use them?
Yeah.
Okay.
Yeah. I'll show you in a moment how that works. So DQ options, this is again for the AQ for dequeuing. So these are just for mostly getting and setting various attributes. And then the NQ likewise. And then here are the methods for lobs. And these are the message properties, again, for AQ. And these are for objects, for SQL objects. So you've got all the different ways to manipulate those. I did, by the way, we changed these to say delete element by index, because at some point we hope to get the associative arrays for index by varchar 2. So in that case, we'll need a new name for those ones. Then we've got object attributes, object types, pools, AQ queuing, SOTA, collections, collection cursors, database, documents, document cursors, statements. Statements have quite a few things as well, because there's lots of different things you can do with them. Row IDs, they're pretty boring. The only thing you can do with them is get a string value. Then you got the various subscription methods, and then variable methods. So variables are used for both binds and defines, and they are, if we look at here, DPI con underscore new var, that's the one that is used regularly. So here you can see that right now connections are hung off of, variables are hung off of connections, not off of cursors, because they can be shared between them. But there's things like lobs and other like ref cursors and so forth that are tied to a connection. So that's why variables are also tied to a connection. There has been discussion about potentially creating variables that don't depend on a connection. Those would be your basic, string, number, dates, but that hasn't been done so far. So you have your Oracle type number, then you have your native type number. So this is how data is going to be provided in ODPI-C itself, either to the database or getting it back from the database. And of course, this is how Oracle wants to see it. Then you've got your max array size. So if you're doing array fetch, which is of course recommended, and the default is 100, then this value would be 100. Or if you're doing a bind, a single bind, then you can make it to 1, that would be fine. Or if you're doing an array bind, batch execute, this would be set to the number of rows that you want to bind at one time. This here tells you what the size of each variable is. This can be 0 for the types that are known, like integers and so forth. It's generally only used for strings and raws and so forth. Then this is a flag indicating whether the size that was provided here is in bytes or is in characters. If it's in characters, then I multiply by the maximum bytes per character. Otherwise, I just take the value as is exactly. This is array flag, indicates whether this is a PL SQL array or not. This is an object type. That's relevant if you're, of course, binding or fetching objects. This is the output variable. And this here is as a convenience. So this returns an array of DPI data structures so that the drivers can access the data directly without having to call DPI var underscore get value or anything of that nature. So this internally here manages all of the memory management that's required. So this makes it quite a bit simpler. In an OCI program, of course, you would have to provide your buffer. You would have to provide your length indicator, your indicators. All these things would have to be provided, return code if that's relevant. So when you bind one of these variables, it handles internally all the necessary calls, OCI bind by pose or bind by name, and of course OCI bind object and bind dynamic and all those things that are needed. That all happens internally when you call DPI statement bind or DPI statement define.
So Anthony, for lobs, are you also recording the length there in that structure? Or you got that special cased?
Which one?
The structure you were showing before, the variable, main variable structure.
This?
Yeah, so if you've got a lob type, you're recording
Yeah.
the size of the lob itself.
0. No, the lobs themselves are, of course, independent objects.
Mm-hmm.
So the size is not known until you call DPI lob underscore get size. Yeah. All right.
So, Anthony, what is the scope of this DPI var? I mean, do you keep them around as long as the connection is there? And how many such DPI vars do you cache?
So what happens is internally, of course, I keep track of references. So when you call DPI con underscore new var, it returns to a variable with a reference count of 1. If you then call DPI statement underscore bind by name, what happens is I internally keep a reference to that variable. And so I increase the reference count. So even if the caller calls DPI var underscore release, because they say they're not interested in that variable any longer themselves, I keep it until the end of the statement. So until you close the statement or until you rebind.
Okay, and what if I say one more, get me another DPI var on that connection? So we create one more?
Yeah. Every time you call DPI con underscore new var, you'll get a new one.
New var, okay.
A new variable, yeah.
Okay, so if there are 10 positions, right, to which I need 10 different buffers, right, different types of buffers. So I call this 10 times new var to get 10 new DPI vars.
Yeah, and then DPI statement underscore bind or DPI statement underscore define as needed. Yep.
Okay, and then I have another statement also that I plan to execute, right?
Yep.
Before closing the previous one. So I need some more new variables. So it creates some more, right, on that connection? Some more DPI vars?
Yep.
Okay. Now, so when do these vars disappear, the memory for these vars? When I close those statements so that the ref count goes to 0, or how is it?
Well, remember when you call DPI con underscore new var, you've been given a reference. So you have to call DPI var underscore release at some point when you are no longer interested in it.
Sure, yeah. So once I do that, let's say I'm done with executing my first statement. I processed all the results, right? Now I say that DPI var release. So does the memory also get cleaned up, or does the connection still cache the connection object? Does it still?
As long as that variable is not used internally anywhere. So if you've used it, DPI statement underscore define or DPI statement underscore bind, and you haven't closed that statement yet, then the variable will be alive still.
Sure, yeah. So once I'm done, and then I'm done with the statement, let's say, right? All the results processed. Then what happens to the var? Does it get freed up?
Yep.
Okay. So there's no caching here, basically, right? It's whenever I need a variable to get it created. There is no caching, right? I mean, so that further statements later will be using that, or okay.
Yeah, caching, of course, be done at the driver level if that's of interest. And I have even considered doing so, like for example, at CX Oracle level, to simply state, like the connection object or the statement object. You might want to just leave that in place with all the variables, so you don't have to worry about recreating it every time. But that's that has not been done so far.
Yeah, OCI has that feature built in anyway, but yeah, the concern is the memory bloat. I mean, because statements can get cached in the statement cache, and if the buffers also are cached along with these statements, it could bloat the memory. But there are some customers who actually use that.
Right. So yeah. So here's the samples. I have a little alias here. Oops. Helps if you run the right thing because they get stuffed in the build directory.
So what does your alias actually do? Does it just set the early library path, etc.?
Yeah, that's all it does. Oh, I haven't actually created the directory. I've created the There. So this is just a sample that sets the application context. If we did DPI debug level, equals 4, then you can see all the different ODPI-C functions that get called. So at the top, you'll see this, you'll see that it just says ODPI, and then this is the thread number, thread ID. And then this is the date on which it occurred, date and time. And then this is the message. So you'll see this 4 is for showing the start and end of all ODPI-C functions. So you can see the first call is the DPI context create, then this init con create params, then to create the connection, prepare a statement, set the fetch array size, create a bunch of variables, set them to values, bind them, then execute, then do some defines and fetches. And then here again, we're doing another one, right? Multiple of them. And I'll show you the code here.
So you have debugging to show the DPI functions being called, but you do not have trace to show the OCI statements being called. I guess we just use the standard OCI tracing for that.
Yeah, that's correct. So maybe before I show that one, there's the sample live.h. So you'll note that in every ODPI-C program, the first thing that gets done is dpi.h. That's the only file you have to include. In the sample programs, I've simply made it convenient for me. I have a main username and main password and proxy and so forth for all the different things I test. So those are just stored in this structure here. And then I've got this simplification, DPI samples get con. All that does internally is it calls DPI con, or if you passed with pool, then it goes ahead and creates a pool first and then gets acquires a connection from the pool. So that's just for convenience. So when I call this DPI samples get params, that gets me all the basic bits and pieces. Here I'm just populating my app context structure with a bunch of data. Then I'm connecting to the database. So here I'm initializing my connection creation params, right, to the default values. And then I simply override the pieces I care about. In this case, my app context. And then I call DPI con underscore create, passing in the context, of course, and then the username, password, and connect string. And the common params is left blank or null, which means you'll just get defaults. And then, of course, here's the parameters that I just initialized up here. And this DPI samples show error is simply another convenience function. So that thing will automatically call DPI context get error if an error occurred, and then fail. So this is how you execute a statement. You call prepare. In this case, I've set the fetch array size to 1 because I know there's only one row that's ever going to be retrieved. Technically, this is not needed. You'll just get the default of 100. Yeah, it wastes memory, but it's not the end of the world, right? This is the Oracle type. So this case is varchar, and the native type is bytes. And we're saying yeses is bytes, and the size is 30, and so forth. And here you got namespace var and namespace data. And then down here, key var and key data, and value var and value data. You'll note I've created these variables here, right? And then I'm calling or setting the value, the variable from the bytes. So you'll note because I'm only actually binding one, this value here is the array position, so it's always 0. But of course, if you're doing array bind, then you would have to set this to multiple multiple indexes. Then I call bind for each of them and then execute. Then I define and fetch. And then I print out the value. So you can see here I'm using value data. Value.asbytes.length. That gives me the length of the string, and this gives me the pointer to the string. And then here you can see this is the cleanup, releasing the variables and so forth. So if I run this again, but I set the 2, this is the reference count. You can see here that what's happening is I'm creating a context, then I'm creating a connection, creating a statement, which a statement internally holds a reference to the connection it was created from to make sure it doesn't go away. Then you create a variable, which also holds a reference to the connection, right? Another variable. So you can see the connection reference count is going up. And then here, of course, because I've bound, calling the DPI statement bind, there's the reference to these variables goes up. And then you can see it goes down afterward, after I close the statement. And the statement goes away, the variable goes away, and you can see that as each variable goes away, the number of connection references go down until finally, at the very end, the context itself goes away. All clear?
Sorry, what was the difference between the DPI var 1 new versus the DPI var 1 later? Is that the decrement when it goes down to 1? Is that what that was?
Where?
Where the cursor is about there. That's versus
Right here?
above where it says new. Is this showing a decrement? Is that what I'm seeing there versus where it says new as the creation?
Yeah, because I mean, this is the actual pointer. So if you look up here, you can see where that one is. 4D FD0.
That's about the fourth new one.
Right up here, where it was created, right? And then here it was added to. That's because I was binding. And now it's going away because I have released the statement. I've closed it. So it no longer holds a reference to that variable. And then down here is when I'm actually calling DPI var underscore release in the program. That's the last reference to that variable is going away. So that means when this goes to 0, it's getting freed.
Cool.
Yeah. So we got the test. I'm not sure if I did this one either. Oops. Oops. Maybe I did. So I have this test suite runner here. This what it basically does is it simply runs all of these tests all at once. So you can run them independently. Like so. And this has the number here, and it tells you how many tests passed. Or
your test ODPI, just for future reference, is just your little alias for personal alias,
setting
the library path. And
yeah, that's all it does.
Yep.
Yep. And if you do this, it's going to run them all. Oops. Of course, if you kind of. And of course, because I'm running this against a 20 database, it will fail because of a bug currently. I think that gives a basic overview of what's going on, so I can answer any questions you have.
Anthony, one quick question. 11.2 and above, OCI bind by position functions takes the size parameter differently, right? One takes UB4, one takes UB8.
What do you mean?
The input parameter, what do you call the size parameter for the bind? 11.2 takes only UB4. But I
Oh,
guess
yeah.
12 and number takes UB8. How do you
Yeah.
deal with that in the code?
Oh, yeah. The other thing I guess that's kind of useful is this file DPI-OCI.c. That contains all of the wrappers on OCI functions. So you'll see here inside here, there's a DPI-OCI load symbol. And all that simply does is it loads a symbol out of the OCI library and fails, of course, if it can't find it for some reason, which should never happen in theory. The other thing that happens here is there's an ensure error handle. So what that's doing is making sure that if we're in a place where we need an error handle from OCI, we go ahead and initialize it. So we delay initializing those error handles until we absolutely need them for an OCI function. So these are all inside here. There's a whole pile of them, as you can see. So this is the structure that contains all of the different function handles, function pointers, and that's what I use for all of these. So you can see here, for example, for the AQDQ, we load the symbol, the name, and tell it to go inside that one. We tell it, yes, we need an error handle, and then we call through the function pointer. And then we have another one, OCI check and return. That's going to check the error. And if there is one, return an error appropriately. So inside here, you can see there's bind by position and bind by position 2. So this one here, of course, is for 11, and this one here is for 12 and up. The other thing that's kind of important.
And then for completeness, just to answer Venkat's question, is which layer of code is then deciding which one of those to call?
Oh, yeah, I can show that too. I can do that first. So here it says if the version number is less than 12, then call bind by position, otherwise call bind by position 2.
So
and the same thing.
So it's all runtime choices that we're making.
Yes. So the other thing that's important, DPI-impl.h, this is the actual implementation file. So this is where you're going to find all of the OCI things. And they're like, for example, DPI-OCI is the prefix I use for anything that comes directly from OCI. So I just stick a DPI underscore in front of all the OCI symbols. So you can take a look at that in here. There's lots of them. And there's also the SQL T ones, right? So this is replicated out of the OCI.h and equivalent files.
Which therefore, just to make it really clear, means that you don't need, at compile time, you do not need OCI.h or anything like that. You don't need the instant client SDK, etc.
Yep. And yes, everything is done at runtime. So this, for example, here is the different pool create parameters at different versions. So this is the one that was true at version 3.0. This is the one that's true at version 3.2. So you can see this one added PL SQL fixup. That was added in 3.2. So I keep all the old structures here. And then these are, of course, all the different ways of representing OCI types. And then here is the implement internal things. So yeah, if you want to get into a lot more details on internal stuff, by all means, we can do so. But here's the external implementation type definition. So these are protected through an opaque pointer. This is, for example, what a pool actually looks like internally, right? It's got your name and your ping interval, ping timeout, whether it's homogeneous and whether you use external authentication and so forth. So these are all defined in here. So this is where you would go if you're interested in looking at details.
So you spoke about the reference counting as one good thing you've done to make it easy for users. Did you want to talk at some stage a little bit about some of the things we've wrapped? I'm thinking about that statement failure where the statement cache may have changed and you re-execute, or the pinging and things for connection pools. A couple of those things we just try and hide Oracleisms or make things just work. Despite things happening in the back end.
Yeah, so when you call DPI statement underscore bind, for example, it simply stores a reference to that variable in an array, an internal array that it keeps. Then when you actually call execute, that's when it actually goes and does the actual binding then. It also, for example, transfers the data from the DPI data structure that was provided by the user to the Oracle buffer structures, because of course they're different. So here, for example, we call statement execute. So all the OCI functions are DPI OCI double underscore, and then the name of the function. If we run into an error, we check the error. If it's 1007 and we haven't, this re-execute flag is simply to prevent recursion. If we've already called re-execute, then we don't call it a second time, right? And this also checks to see whether we should delete from the cache or not. If an error occurs, we delete it from the cache so that it can't cause problems in the future.
So the reasons for this are that the statement cache has some cases where it doesn't get invalidated. If somebody does a drop on a table and changes the data type of a column, the metadata stored in the client, Oracle client, may be out of sync with what's in reality in the database. So you try and execute and you get an application failure. So here in DPI, what you're doing is just saying, oh, look, I think it's going to be a problem with the statement cache. I'll just drop and then re-execute the statement silently and obviously then fix up the statement cache. So the user of this won't know that there's an issue. And basically, we're working around a limitation of the statement cache to make it nicer for the users.
Yep. So here you can see this is the actual code here, because all it does is it first acquires using add or get the name of the statement itself. And of course, if that fails, then you just let the whole thing propagate the error. And otherwise, we go ahead and call prepare statement prepare 2, which is going to get a new statement out of the cache that just doesn't have the original problem. And a little jiggery pokery to make sure that it's associated and the user doesn't know. Then, of course, we have to redo the binds. And then we call statement execute again, this time passing in 0, saying don't re-execute if you get the same error again, 1007. So yeah. Anything else?
I don't know with the connection management, it seems to be a big topic for our end users, but some of the connection pinging and server status checks and things like that, the error message checks you do to see whether you got a fatal or connection invalid kind of error.
So this is the method that's used. It says, ping and loop until we get a good session. So you can see that here. What happens is we call OCI session get, like normal. We get the session and server handles. And then we go ahead and call context get value. So on the connection itself, we store a bit of context. In this case, the last time this particular connection was used. If we didn't find one, or if we're not in a pool in the first place, because you can call OCI session get when you're not in a pool for a standalone, then we go ahead and say, yeah, we're okay. We've got a new session and we're good to go. If the ping interval is negative, it means we've disabled this feature. or the last time that was used, plus the ping interval, exceeds the current time, then we're okay. Otherwise, we go ahead and check the, we get the original received timeout, and then we set it. And if it's greater than 12, we also get the break on net timeout and set it. Then we call ping. And again, if there's a problem, we reset the break on net timeout back again. But if the session was bad, in other words, we didn't break out of the loop, then we destroy it, and then we go back and do the whole thing over again until we actually get one.
So the rationale for that is that users don't like doing error checking. They just want the call to whatever Oracle driver they're using to give them a usable connection all the time. And particularly in development, they'll be closing a laptop lid and opening it again. Network will have dropped out. So the session pool in their client and they're running on their laptop is not going to have a valid network connection to the database, and connections that they would get from the pool would be unusable. So the sort of ping interval is a way to get around that. Obviously, well, not obviously, but most of you probably know that the later versions of the OCI get session also do low-level checks as well. So definitely advantages to users using latest versions of everything to try and, again, just make sure that a connection that the application gets is totally valid, and that then they minimize the number of times they go through their own error code handling.
Yeah. The other one that's kind of interest is this DPI-CON double under close. This is used for actually closing a connection. So the first thing that happens is we roll back any outstanding transaction if there is one in progress. But the next thing that happens is I close all objects. So and also lobs and statements. So what happens is when you create a new statement, I keep an internal list of all the statements that are opened, and likewise for lobs. And that is because depending on how you do things, and depending on what version of Oracle you're dealing with, it does not clean up these things so you can get memory leaks. So this kind of works around that. So that's objects, statements, and lobs. And then down here, it checks to see whether we've got a dead session or not. And if so, it's going to destroy it. So in here, you can see that if we haven't done last time used at all, then we go ahead and set it so that when we get a session next time, we can check the time. So that's done in the close as well. A lot of these things are done to make sure that all this stuff gets cleaned up automatically, and you don't have to worry about memory management quite as much as you would in a regular OCI program.
The other major thing, which I think you're wrapping a little bit, is the lob stuff. We have talked a bit about it, but do you want to show how you're fetching lobs as strings?
Oh, yeah.
So again, most people just want data. They just want things to work. Give me a connection which works. Give me my long data. Most people are not writing video applications. They don't need huge amounts of lob streaming capabilities. They just want a longish string.
Yeah, so this is the method that's used for allocating the memory needed for a variable. So there's a bunch of checks that are made, right, to make sure that everything's good and happy. But eventually, you'll see here, it says if the size in bytes is greater than the max basic buffer size, which is defined, then we set it to dynamic. And so we actually do dynamic fetch, which I will show you. DPI var init buffer is what actually allocates the memory. So you can see there's plenty of memory that gets allocated. You got the indicators, you got your actual length, and of course, depending on whether you're using version 11 or 12. You have to deal with 16-bit or 32-bit actual length. And then you've got the return code. And for numbers, I also add support for transferring numbers as bytes. So there's an allocated additional set of buffers for that. And then, of course, the external data array, if that's needed. And an array of references for lobs and statements and so forth. And then variable specific. So here you can see descriptor allocations as needed. So here is the outbind callback. So this is going to allocate memory as needed. So what happens is ODPI-C will retain an array of buffers. And then when all of the buffers have been allocated, it will allocate one buffer to store all of it, if the user asks for that. So that's what this DPI dynamic bytes chunk business is about.
So can you say that again? If they've all been allocated, you allocate one to store all of it. Can you?
Well, to consolidate the buffer into one piece.
Okay.
Yeah. Because if you actually look at the data, you want everything in one chunk. You don't want bits and pieces. I don't know, but as far as I remember, I don't even give the drivers the option. It just does it. So obviously, if you've got a large lob, you're probably not going to want to do it using dynamic chunks like I've done here. But if it's small enough, small meaning, you know, a handful of megabytes, or even up to like 30, 40, 50 megabytes, that size is perfectly fine and is substantially faster than retrieving a lob.
And that the technical limit is 1 gigabyte.
Yeah.
Next question from me.
Yeah.
Do you want to talk about prefetching, array fetching, what you're doing, and then that?
Prefetching?
Well, how you're handling it all.
Okay, well, we did this recently. This is to set the Boolean indicating that prefetch length should be done. But down here, we say if the statement type is query, we use the default, which we've set to 2, and we set it. It's not controllable by the drivers or applications.
So the one you just quickly flipped over was the lob prefetch, which is slightly different. So this is the row prefetch we're looking at on screen.
Yes.
Yeah. And really what I was getting to was the fact that you're actually doing array fetches.
Oh, yeah, yeah. Yeah, array fetch is done by default with 100 rows being created by default.
So the row prefetch is 2 by default, Anthony, that we are using?
It's fixed to that value, yes.
Yeah, 2, right?
Yeah.
Okay. Yeah.
Yeah, you can see that in here, 2.
But that definitely has advantages. Actually, I was testing that in SQL Plus the other day. That the default in SQL Plus is not 2. When you set it to 2, you can reduce the round trips for single row fetches. However, there are some limitations if you're playing with ref cursors and you want to pass ref cursors around, but we've already prefetched a row from it. So there's a small limitation. We haven't seen too many issues, but maybe at some stage we will need to expose this as a knob so people can set it back to 1 or 0. So thank you very much, Anthony, for that presentation on ODPI-C. And you can find us online on GitHub, etc., and ask any questions.